All right, Algebra 2 trig. We're on to Unit 3.6, polynomial functions. We're going to find the x and y intercepts, and we're going to talk about what end behavior is, and this is going to lead into the graphs of polynomial functions for Unit 3.7. All right, we talked about finding x and y intercepts for quadratics, so this first part is just review. So if we look at each of these graphs, we can see that they're parabolas, they're quadratic graphs. So we can find the x-intercepts, which are where the graph crosses the x-axis. So on this first question, part A, we can see that the x-intercepts occur at -1 and also at +2. And then the y-intercept, we can see occurs where it crosses the y-axis at +2. All right, and then on B, we can do the same thing. We can see it crosses the x-axis here at -1, and then again 1, 2, 3 at +3. And then the y-intercept, we can see it crosses down here at -1, 2, 3, -3. All right, so let's keep going. So zeros, x-intercepts, solutions, roots, they all mean the same thing. So a zero of a polynomial function is defined as the solution to the equation. So if we were to take that solution and we synthetically divide into that polynomial, we get a remainder 0. All right, and so when we have the factors, we can set the factors equal to 0, and we can solve for x. Those solutions are also the zeros, which are also the x-intercepts. Right, so when we're graphing, we're trying to find out where the graph crosses or touches the x-axis. So we can talk about zeros, solutions, roots, x-intercepts. Again, they all mean the same thing. So when we're trying to find these x-intercepts, it's easier to find it in factored form. And if we want to find the y-intercept, then just like before in Unit 2, we're going to replace all the x's with 0, and then we can simplify solving for y. All right, so let's take a look at each of these examples. We're going to find the x and y intercepts for each one. So on number 2, the equation, the polynomial is already factored, and so we can take each of the factors and set them equal to x to get the x-intercepts. Okay? And so we can see for -x, that's going to give us an x-intercept of 0. For x plus 3, it's going to be -3. For x minus 2, it's +2. And for x plus 1, it's -1. Again, we could take each of those factors, set them equal to 0, and solve for x. And these are the x-intercepts that we would get. So when we want to find the y-intercept, we can replace all the x's with 0 and solve for y. Right? So if we take this equation, just replace all the x's, and then 0 plus 1. And so then if you simplify this, -0 is 0, times 0 plus 3 is 3, times 0 minus 2 is -2, times 0 plus 1 is 1. And if you multiply all that together, we're going to get 0 for the y-intercept. 0 times anything just gives you 0. All right, so number 3, looking at a graph. Again, the x-intercepts are where the graph crosses the x-axis or touches it. So we can see there's one right here at -2, another one at +1, and then another one at +3. The y-intercept, we can see it crosses up here at +2. Okay. Number 4, similar to number 2, we have the equation. It's already in factored form. So the 4 on the outside, because there's no x with it, we can ignore it for the x-intercepts. The x plus 2 is going to give us a -2 x-intercept, and the x minus 1 is going to give us a +1. The y-intercept, we're going to replace all the x's with 0. So that's 4 times 0 plus 2 times 0 minus 1. And we can just work that out. That's going to be 4 times 2 times -1. So 4 times 2 is 8. 8 times -1 is -8. And then 5, similar to number 4. our x-intercepts, positive 1, negative 1, negative 2, that's going to be positive 2, and negative 3. And then the y-intercept, we'll replace all the x's with 0. Remember, f of x and y are the same thing, so when you see the function notation, you can just replace it with y. All right, so 0 minus 1, 0 plus 1, 0 minus 2, and 0 plus 3. All right, so 0 minus 1 is negative 1, 0 plus 1 is 1, 0 minus 2 is negative, 0 minus 2 is negative 2, and 0 plus 3 is 3. Multiplying all this out, negative 1 times 1 is negative 1, times negative 2 is positive 2, times 3 is positive 6. All right, so let's keep going. All right, so it says find the x and y intercepts of each. You may have to factor first. Remember, factoring helps us find the x-intercepts easier because the x-intercepts, again, are just the solutions. All right, so our x-intercepts, since 6 is already factored for us, the negative 2 we can ignore because there's no x with it. For the x plus 1 factor, we're going to get a negative 1 x-intercept. For x minus 3, get positive 3, and x plus 4, negative 4. The y-intercept, we have to replace all the x's with 0. All right, so we simplify this down, and then multiply it out. Negative 2 times 1 is negative 2, times negative 3 is positive 6, positive 4 is 24. All right, number 7. So this polynomial is not factored for us, so we can factor it. There's 4 terms, so we can use grouping. So we pull a GCF out, x squared. Negative 4 comes out. So x squared minus 4, x minus 1. And then x squared minus 4 is a difference of squares, so we can factor that one further. So that's factored all the way. So now we can get our x-intercepts. So for x plus 2, we're going to get negative 2. For x minus 2, positive 2. And for x minus 1, positive 1. The y-intercept, we can replace all the x's with 0 and do the same thing. When it's in standard form, like number 7 isn't factored for us. If you remember from the quadratics unit, if you put 0 back in for all the x's, it's just going to be the constant term. So you can see the constant term is positive 4. So, but we can check it again by plugging 0 in the factored form, and we should get the exact same answer. All right, so 2 times negative 2 is negative 4, times negative 1 is positive 4. Again, when it's in standard form, it's going to be that constant term. All right, and then last one on this is number 8. It's in standard form, so that means they didn't factor it, so we want to factor it. And looks like there's a GCF of 4x squared. Pull out. And we'll be left with x minus 2. All right, so our x-intercepts, we can set 4x squared equal to 0 and solve it. And we're going to get 0 for an x-intercept. And then for the x minus 2, we get positive 2. The y-intercept, we can replace all the x's with 0. And you can either put it into the standard form or into the factored form. Regardless, you'll get the exact same answer on this. It should be 0. All right, so then that's how you find the x and y intercepts, and now we're moving on to end behavior. So the end behavior tells us what the arrows are looking like in our graphs. All right, so real quick, the shapes of these polynomial graphs are going to be these continuous curves. So they can look something like this. They could look something like this. So you can see that both examples, they have two arrows, one on the left and one on the right. And they can either be pointing up or they can be pointing down. They can both be pointing up, they can both be pointing down, or they can just go in opposite directions. So this is what the shapes of these graphs are going to look like. All right. So that's what end behavior is. It's what are the end arrows, the two arrows doing? Are they going up or are they going down? All right, so the direction, the left and right arrows in which they point either up or down is going to help us get our graphs. So we want to memorize two parent functions from, I think it was unit 1. One of them is the y equals x squared, and the other one is y equals x cubed. Okay, so we have the quadratic and the cubic. All right, so anytime our degree is an even degree, so an even degree meaning the polynomial's highest exponent, if you were looking in standard form, is an even number like 2, 4, 6, 8, 10 kind of thing. We want to think of the parabola shape, the quadratic. So our shape would look like this. That's what x squared looks like. So that means that all even degree polynomials, both arrows would be pointing up. That's the end behavior. The left arrow and the right arrow both pointing up. Now, if we lead off with a negative, that means there was an x-axis reflection. So that means that both arrows now would flip over and point down. All right, so if it's an even degree, both arrows are going to point in the same direction. Either they're both pointing up or they're going to both point down. Now, if it's an odd degree, so a degree like a 3, a 5, 7, 9, that kind of thing, then we want to think of the cubic shape. All right, so the cubic shape is that S shape. So it kind of looks like this. So it's down on the left and up on the right. So the arrows are going to go in opposite directions. Now, if there's a negative in front, then it does an x-axis reflection. So it's going to go up on the left and now down on the right. All right. So those are the kind of the shapes that we want to memorize. All right. So the degree of a polynomial in standard form is always going to be the highest exponent of the variable. So we talked about this. So in the example y equals x to the third minus 4x plus 5, the degree of that polynomial is 3, because 3 is the highest exponent. Now, if it's in factored form, what we do is we add up all the exponents of the factors. Okay, so, and again, the factors have to have an x counted. So on the x on the outside, that has an exponent of 1. Okay, plus x plus 3 has an exponent also of 1 on the outside. And then x minus 1 squared has an exponent of 2. So if we add 1 plus 1 plus 2, we're going to get 4. And so that's how you find the degree of a polynomial in factored form. All right, so what we're going to do for each of these, we're going to state the degree of the polynomial, and then we'll state up or down for the direction of the left arrow and the right arrow. All right, so number 1 is in standard form. So standard form, we take the highest exponent, and so the degree would be 4. Now, because 4 is an even number, okay, and we're leading off with a positive number, it's positive 3. Doesn't matter what the number is, it's just, is it positive or negative? We know the shape, both arrows are going to point up. Right? So the left arrow goes up, and the right arrow is going to point up. All right, number 2. Again, this is in standard form. The highest exponent here is 3, so the degree is 3. Now 3 is an odd number, right? And since it's an odd number, then we want to think of the cubic, okay, the cubic shape. So it would be up on the right, down on the left, but because of the negative, it flips over the x-axis. So then this is what our shape is going to look like. So it's going to go, the left arrow is going to go up, the right arrow is going to go down. All right, number 3. This is in standard form, so the highest exponent is 6, so the degree is 6. 6 is an even number, so we know it has to have the quadratic shape. But because we're leading off with a negative, it's going to flip over the x-axis, and now both arrows will be pointing down. And so left is going down, and the right is going to point down. All right, let's see, number 4. Now we're in factored form. So factored form, we have to count up all the exponents of the x's. All right, so x plus 3 has an exponent 1 out here, plus x minus 4 has an exponent 1, plus x plus 2 has an exponent 1. And so if we count up all the x's, which are the exponents, 1 plus 1 plus 1 is 3. So this has a degree 3. 3 is an odd number, so that means it's going to have the cubic shape. And we're leading off with a positive number, and so there's no reflection. So we want to think of our cubic shape like this. So the left side's going to go down, and the right side's going to go up. All right, 5 is also in factored form, and so we count up all the x's of the exponents. Okay, so x plus 4 has an exponent 1, x minus 5 squared, exponent 2, and x plus 5 has an exponent 1. So 1 plus 2 plus 1, that's 4. All right, 4 is an even number, so we want to think of the quadratic shape. We're leading off with a negative, so it flips over the x-axis. So the left is going to point down, and the right's going to point down. And then the last one, number 6, again, factored form. We want to count up all the x's. So 3x has an exponent of 1, plus x plus 7 has an exponent of 1, x minus 6 has an exponent of 1, and x plus 6 has an exponent of 3. So we want to add all those up. So 1 plus 1 plus 1 is 3 plus 3 is 6. So this has a degree of 6. All right, and 6 is an even number, so it's a quadratic shape. And we're leading off with a positive 3, so that means our shape, both arrows are going to be pointing up. All right, and that is it.